This video is for the third prompt for October 12th. This one's going to be an introduction for the first time really to a very new tool. In the same way previously in prompt 1 we were introduced to cell statistics. We're going to be introduced to another statistics tool here, but this one is zonal statistics. The way this prompt is set up, right, for each county in Maryland, I want you to tell me what is the land cover that occurs most in 2011 and what percent of that county's total area is accounted for by this land cover type. So essentially, let's do the counties with the coastlines so that all this water doesn't throw it off for some. Right, if I just maybe make them have a broad, thick red line on the outside, you could probably see a little more what I'm wanting, right? In the same way that we might use a spatial join. This is almost like the spatial join in the raster world, where you might take a spatial join and ask every county to sum up the population or to sum up the crime or the businesses or some statistic, right? We've done this before with spatial join that are in its boundaries. Let's do the same thing with raster, right? That could be super useful in any number of ways. Perhaps you have 10 or 15 sites that you want to evaluate to potentially build something on, but you need to understand the topographical change. So you could do a summary for each site to see what the max elevation change is, right? The max slope grade change. Or maybe you have a raster that is population density or average home sale price, and you want to see, for a series of neighborhoods, which has the highest average density or the highest crime density or the highest home sale range. But it can be tough, to do that with a spatial join, actually impossible, because it's not a vector, right? That information, home sale price, elevation, slope, it's all contained within pixels, right? We can always zoom in super close and remind ourselves that those values contained in the pixels are representing some quality of space, right? Not an object, geographic space. So, how do we run that operation? How do we create something where each of these boundaries here is going to summarize what's going on inside of it? And we do something that's called zonal statistics. Right, so if you'll remember, back in prompt 1 we went into local and we did cell statistics. Right, the way that worked was it was almost like if we just imagined this pixel here. It was almost like we just looked at that pixel in this grid and in this grid. Unfortunately, that one happened to be the same, so it didn't look like much changed. See if I can find one where there's a little bit of change, maybe. Might be harder than I had thought. There we go. There's some nice little change up. Right, so we looked at a grid, maybe this exact one here, and we looked like, what is your value in 2011? Okay, you were urban. What were you in 2006? You were herbaceous. What were you in it's perfect. What were you in 2001? You were forest. Right? We draw the pencil, drop through the graph paper for each pixel. Each pixel had no idea what was going on around it. All each pixel happened to know was, this is what my value is in 2001. This is what my value is in 2006. This is what my value is in 2011. That was cell statistics. We took all those values and we ran some equations, sum, average, median, mean, whatever was justified by that operation. What we are going to do now is the same kind of process, except the types of cells that are going to calculate themselves together, they're not the same cell spread across multiple grid layers. It's going to be all of the cells within one grid layer, like we're only working on 2011 right now. And what unites those grids, like what's going to allow the cells to have individual calculations, is going to be some zone that you establish. In my instance right here, that zone is going to be the counties. Right? What differentiates these counties? They each have their own ID. Sometimes it's encapsulated in a name. Excuse me, I meant to do a label. Right? What is this? That is not at all what I wanted you to do. What in the world was that? I'm not doing that anymore. Come back here. Oh, I think I know exactly what the problem was. Because there's all these little islands and coastlines, they treat each other as like individualized spaces. Sorry about that. Turn your label off. So you not see those thousands of elements for each component part. Right, but essentially I can open this up. And in terms of counties, right, I click something like this. That is Allegheny County. And that is different than Baltimore County. And it's different than Westmoreland. And it's different than Washington. Right? And it's different than this. And it's different than Frederick. And it's different than Carroll. And it's different than Baltimore. So that's the purpose of what we are doing here. Each individual county, we can see name seems to be that great field that separates them, is a zone that only contains its boundaries. And so what we want to happen is we want everything that happens to be in Franklin County or Baltimore County to run a statistic with only cells in that county, right? Same way that if you wanted to summarize crime trends in a neighborhood, you wouldn't be summarizing the, assaults in East Falls by looking at assaults in Mount Airy, right? You'd be saying, Mount Airy, you're here, do your own calculation. East Falls, you're here, do your own calculation. That's what we're trying to emulate here. So you do it in two ways in zonal statistics. You have two options, zonal statistics and zonal statistics as a table. We'll probably dive a bit more into zonal statistics in class just because the output is a little bit more complex. It's pretty straightforward output what you get for as a table. So take zonal statistics as a table. It's going to want to know two things from you. First is, what are the zones? So that means where are those borders of demarcation where I'm going to do one calculation for one thing and another for something else. And that is the coastlines, right? A critical field here is the zone field. If you do not specify this, if you just assume that ArcGIS has your back, you're going to run into a problem here. What this field is saying is, what is the value that's used here to help me understand what the difference is between one zone and another. So if I did nothing and I just kept it as state FP10, then that would be a zone, right? State FP10. This would be another zone, state FP24. Right? The zones would no longer be by the names of the counties, they would be by this field. I'm not even sure where this came from, but this field, this identification, that would be what defines it. But what we want is the name, right? That's the field we know that there's unique values for, so therefore that's the one we want to leverage. So you always want to make sure when you're using zonal statistics, pause and tell yourself, what is the zone, right? Okay, the zone is counties. What attribute do I have that differentiates one county from another? This attribute. Value raster is essentially what you want to do a statistic of. So let's bring in MD 2001. Now, pause for a quick moment here. This may seem a little bit counterintuitive at first, because it's going to ask us for a bunch of statistics, right? Mean, majority, max, min, so on and so forth. But this is not the best grid to do statistics on, right? There's no real way to do like an average here or a sum. I can't do an average of, what if I have like a bunch of develops that are 21 and a bunch of forests that are 41? It's really meaningless to bring them together like an average. If I had a grid of population density or crime density or elevation, that's great. I could do an average all I wanted. But I'm working with a nominal grid here. But return back to the question, right? The question is, tell me what land cover occurs the most, right? It's kind of similar to the prompt in the first one. How many different varieties of land cover? And so when you want to know what value, right, what land cover, what value occurs the most or the least, you can use majority or minority, right? So majority, minority, and variety are three that can be used on nominal, ordinal, and continuous rasters. So what I'm going to be saying here is it's essentially going to bring me back a table that'll tell me each name, right, each county's name, and then it'll tell me the value that appears the most. 11, 21, 22, 23, 24, 31, whatever it happens to be. Right, all I asked for was a table, so that's all that comes back, and there we go. The neighborhoods or the given counties each year telling me what happens the most. 82 happens the most. What happens you the most? 41 occurs the most. What happens in you the most? 82, right? So it's telling you the different land uses, and I can always go back and look at those values and find out, okay, 41 was deciduous forest. That's the one that happened the most in these ones. 90 occurred in Worcester. Let's find 90 happens to be wetlands, right? So woody wetlands happen the most there. That's how you solve the first prompt. The one area I want to leave a little bit open is how you'd solve that second part. You already have the tools to do it. See if you can figure out, now you know what land use occurs the most, how do you figure out how much of that land use is now within each county? So I'll let you play around a little bit with some of the logic to solve that. But you know that you have the tool Zonal Statistics at your disposal.